This equation is already considered as a homogeneous equation. Part of the proof showing that is already presented in the previous video. Please review that because this video will only focus on solving this homogeneous equation. To solve for homogeneous equation, we are going to use here the process of substitution. As to what we need to substitute, it depends now on the given equation. We can let a certain variable, of course you only have two variables here, x and y. We can let any of them represented by the other with a certain, introducing a certain variable. Let's say x could be represented as vy, as we introduce variable x, v rather. Or we could also say y is equal to vx, depending on the situation now. This would also help us that once we take x equals to vy, dx will also be different, similar to dy here from y. Okay, so it depends now which would be used. Now the point here is, or the hint is, which of these two representations will be used is on our given equation. Look at our dx and dy. Which of the two contains or paired with a simpler form of expression? That's actually dy here, as it is only paired with x. And with that, we're going to say that our dy here, our dy is what we are going to substitute. This is so that we will have an easier computation later. So if it's dy as presented here, again as mentioned, it has simpler coefficient x here, or variable x. Our dy is the derivative of vx, as y is equal to vx. And if we have a product of v and x, that the derivative of that is when we take the sum of two expressions where a combination of a derivative of the other in the original form. Let's say this would become v dx, as we take the v as itself and the first derivative of x. Then you will have here plus, you will have here x dv, as we also take the original form of x and derivative of v. Now we're going to use these two on our substitution process here. So it would be like this. Instead of x minus y dx plus x dy equal to 0, we now have the this representation for y and dy respectively. This will become x minus your y, which is vx, dx, plus x in your dy is actually v dx plus x dv equal to 0. Okay, now that we are done with substitution, we simply need to manipulate this and make sure that we can what they call this one, isolate dx or dv now instead of dy. So when you look into this, it will become x dx minus vx dx. Now there are some references who will not do this, but because they are on the same derivative here, dx. But I'm just going to do it like this to illustrate the further process. Here, because you will have here vx dx and plus x squared dv equal to 0. As you substitute your x here, just like that. In short, you will see that something like this that will be already removed. You will have here x dx plus x squared dv equal to 0. Now from here, what we need to do here is to separate our variables. In short, we are going to manipulate this in such a way that what will be paired for dv will only be variables with v, and for dx will be variables of x. And since x squared is here, we're going to remove that by multiplying both sides by 1 over x squared. This would mean, once you do that and multiply that on all terms, x over x squared is just 1 over x dx plus dv only equal to 0. This time we have separated the variables and we are just going to solve this by integrating both sides. You will have here the integral of 1 over x dx plus the integral of dv is equal to the integral of 0. Of course, this is the integral of, you can rewrite that actually as this if you would like to. Let me rewrite this. Okay, that's actually dx over x, and the integral of that is the natural logarithm of the absolute value of x, plus the integral of dv is actually equal to v. is equal to the integral of 0, which is just any constant c. Okay. Now that we are done with this, we are almost there. Take note that we have here our v, okay, represented by our v. What was our v earlier? Our v earlier is, or will be taken from this representation of y is equal to vx. In short, our v is x, it's y over x. This is the value or the representation for v as what we used earlier for y is equal to vx. So with that, again, v is equal to, what was that? Y over x. So y over x. Since it's like that, so simply substitute the natural logarithm of x plus y over x is equal to c. If you don't like this, you can always multiply all terms by x. And finally, you will get your solution here. X, natural logarithm of x plus y is equal to cx. And this is already the solution for this. Or if you would like to really use or get the representation in terms of y, you can have y is equal to cx minus x, the natural logarithm of x. You can also have this. This is now the solution for this identified homogeneous equation. Again, the process involves substitution, and on substitution, we pick which would be easier notation for derivative in terms of which of the two has simpler expression, and then we're going to work on that and substitute all the representations and solve by separation of variables. Thank you very much for watching.